Hey, good morning, everybody. Today we're going to finish up chapter 4 and probably start chapter 5. And that'll be our last full set chapter, because chapter 6 only has 2, maybe 3 sections, but they're all related. So that'll go in pretty much one day. Right. So in this section, we're dealing with polynomial and rational inequalities. Remember, polynomials has many terms, and rationals are fractions. So we're doing inequalities now. We'll look at polynomials. Polynomial inequalities. Would be something like x squared plus 5x plus 6 is less than 0. So here are your steps. Remove any parentheses. Move everything to one side. Factor the polynomial function. Find the x-intercepts. Find the intervals around those intercepts. Choose the value in each interval. And plug it into a polynomial. Right. Polynomial on one side, you have a 0 on the other side. If p of x is less than 0, because if we had this polynomial, if the value you put in there makes the equation equal less than 0, then use that interval. If the value you put in there is greater than 0, do not use that interval. And that's pretty much all there is. There's a note here. Remember what we said when we first dealt with inequalities? Treat inequalities like equal signs when you solve them. Let's go back to this one. Let's have this. X squared plus 5x is less than negative 6. There aren't any parentheses. Move everything to one side. In other words, set that equal to 0. In other words, So I got to add 6 to both sides. So we have x squared plus 5x plus 6 is now less than 0. That's step 2. Factor if possible. So we got x, x. They're both the same. They're both plus. What times what is 6? When you add them, you get 5. 3 and 2. Find the x-intercepts. Set them both equal to 0. And solve. So these are my x-intercepts. We know our y-intercept is 6 because of that. We have our x-intercept at -2 and 3. So if we go 2 up 6, that means if we go 2 here and up 6, we have another point. Now, if we draw the graph, you can see where the solution is already, because we're looking for an interval of answers. Since we want this equation only where it's less than 0, that's here. That's between -3 and -2. That's your solution. But let's follow the rest of this thing. Our intervals are from -infinity to -3, from -3 to -2, and from -2 to positive infinity. So from -infinity to -3, we have this part of the graph. -3 to -2, we have that one. And then the rest of it here is from -2 to infinity. Choose a value in each of these intervals. So I'll use x equals -4, x equals -2.5, and x equals 0. If you can use 0, always use 0. So that's what we did here. Plug each of these into there, our factored form. Or you could put it here if you want. This one's a lot easier. So we have x plus 3 times x plus 2. Remember, we want it to be less than 0. If it's less than 0, that's a good number. So put in -4 here. So we have -4 plus 3, -4 plus 2, -4 plus, here I have 2.5, -2.5 plus 3, -2.5 plus 2. Is that less than 0? And then here we put 0. X 0 plus 3 0 plus 2, is that less than 0? So let's work it out. Negative 4 plus 3 is negative 1. Negative 4 plus 2 is negative 2. Negative is a positive. Is 2 less than 0? No. So we can't use that interval. Negative 2.5 plus 3 is positive 0.5. Negative 2.5 plus 2 is negative 0.5. Positive times negative is negative. So all we really care about is the sign. And that's why we set it equals 0. We just want to make sure that the number here on this side is at less than 0. And that one is. So we can use that. That's what I said earlier. 0 plus 3 is 3. 0 plus 2 is 2. Is 6 less than 2? No. So we can't use that. So our solution is that. All right, so let's look at example 1. This is from the packet I gave you last time. This one. Example 1. X squared minus 4x minus 5 is greater than 0. There aren't any parentheses. Everything's on one side. We have a 0 on one side. So now all we do here is factor. That's a minus, so the signs are opposite. And the bigger number gets the negative. What times what is 5? When you subtract them, you get 4. 5 times 1, 5 minus 1. So the 5 goes in the negative because of that. We set these equal to 0. We have to find the x-intercepts. So x is equal to negative 1 and x equals to 5. So we see here that our x-intercepts are at 1 and 5. So our intervals that we're going to look at are these. So we choose a value on this first interval between negative infinity and negative 1. That's this one, that side. Then we have from negative 1 to 5, the next interval. And then the last one is from 5 to infinity. Remember, we're looking for x values that will make this equation greater than 0. So I'll use a point in here. Let's use x equals negative 2. If we can use 0, always use 0. So we use 0 here. And this one we'll use 6, because it can't be the end point. It has to be something inside that interval. Plug those x values inside your equation. Only use the factored form if you're for sure confident that it's the right factor. Because if the factor is wrong, you can plug anything into it, the answer will be wrong. If you're not sure about it, then go back to the original equation and plug your values in there. So anywhere I see an x, I put a negative 2. Negative 2 plus 1. Negative 2 minus 5. This one's in this middle one, it's 0, 0 plus 1, 0 minus 5. And this last one, it's 6. 6 plus 1, 6 minus 5. These are our test values. Because if the test value, remember, it's in these intervals. The x-intercept stops here and here. So I go from negative infinity to negative 1, from negative 1 to 5, and then from 5 to... So then I pick values inside these intervals. And since our equation is greater than 0, we're only looking for answers that are positive. Negative 2 plus 1 is negative 1. Negative 2 minus 5 is negative 7. Negative and negative is positive. 1 times 7 is 7. That one works. So this interval works. 0 plus 1 is 1. 0 minus 5 is negative 5. Positive, negatives, and negative. Is negative 5 greater than 0? No. So we can't use that interval. 6 plus 1 is 7. 6 minus 5 is 1. Is 7 greater than 0? Yes. So our solution is this interval. Because we're only looking for where it's positive, where it's greater than 0. Because that's what the original equation says. Where is this polynomial greater than 0? Well, we also should know about if we just graphed this equation. Once we found the x-intercepts, we know the y-intercept is negative 5. It's quadratic, that's positive, so both ends go up. So the only place this function is positive is on this interval and that interval. So again, if you remember how to graph these things, it's a lot easier for you. Let's look at example 2. X squared plus 3x minus 5, x plus 3. There aren't any parentheses. Check. So we have to get equal 0. So we have to move everything over to one side. So I subtract x, and I subtract 3 from both sides. So I got x squared. Positive 3 minus 1 is a positive 2x. Negative 5 minus 3 is negative 8. Remember, since this equation is less than or equal to 0, what we're looking for are the intercepts and wherever the graph is below the x-axis. That's what we're looking for here. Anything above it is not going to work. X and x, negative, so it's positive and negative. 4 times 2 is 8. 4 minus 2 is 2. So the 4 gets there. Factor those. Find our x-intercepts. X equals negative 4 and x equals 2. Yeah, we looking at this equation here, we know it's quadratic. It opens up. So our graph will look like this. We're only looking for areas that are less than or equal to 0. So we want, what this means, we only want parts of the graph that are below the x-axis. So the only place that happens is in this interval here. So your answer is from -4 to 2. And since it's equal sign, we have to put brackets there, because we can include the endpoints. Any questions? No questions? Sure. Okay, we'll do number 3 then. For the rational inequalities, first step, remove any parentheses. Move everything to one side. Set it equal to 0. Find any vertical asymptotes. That's where the bottom is equal to 0. So set the bottom equal to 0 and solve for x. Those are your vertical asymptotes. Set the tops equal to 0. Those are your x-intercepts. Combine the two fractions, simplify, then find the intervals. The intervals will be defined by your critical values, which are the vertical asymptotes and zeros. And then find test values and see which intervals work. Same thing is, if your polynomial is less than 0, or if your polynomial is greater than 0, if it's less than 0, we want below the x-axis. And if it's greater than 0, we want the intervals that are above the x-axis. That's what it tells us. All right, let's look what we have here. Let's find an example here. Example 5. Three x over x plus 6 is less than 0. We don't have any parentheses. It's everything's moved over to one side. We have 0 one side. So what are my vertical asymptotes? Set the bottom equal to 0 and solve for x. Then find the x-intercepts. Set the top equal to 0 and solve for x. There's nothing to combine. There's nothing to simplify. So we have our x-intercept there, 1, 2, 3, 4, 5, 6. We have another one there. -6 is your vertical asymptote. So what are my intervals? -infinity to -6, -6 to 0, and then very good. Yes, I knew what you were going to say. Those are my three intervals because I have two critical values, so I have three intervals. Now we pick a test value. Let's pick on this first one, -7. In the middle one, -1. And the last one. I mean, you can pick any numbers you want. It doesn't matter as long as it's inside the interval, not at the endpoints. Plug each of these in your equation. So what kind of answers are we looking for? Positive or negative? Negative, because we want less than 0. So we plug in -7 in there. 3 times -7. -7 plus 6. Three times -7 is -21. -7 plus 6 is -1. Negatives cancel, so we have, is 21 less than 0? No. So we can't use that interval. How about be -1? 3 times -1, -1 plus 6. So we have -3 over 5. Is that less than 0? Yes. And that 1. 3 times 1, 1 plus 6. 3 over 7. No. So the only interval that works is this middle one. What's this graph going to look like? What's the horizontal asymptote? We have the vertical asymptotes at -6. What's the horizontal asymptote? Since the function is 3x over x plus 6, 3x over x. The x's cancel, so it's just 3. The horizontal asymptote is 3. Again, those are the 3 tests we had last time. What this graph is going to look like pretty much is something like this. because we have an x-intercept of 0. Everything between here is going to be negative. These are your asymptotes, so the graph gets infinitely close to them. So your graph will look something like that. We only want what's below the x-axis. That's that one. Okay, let's look at number 6. X plus 1 over 2x minus 4 is less than or equal to 1. So what's the first thing you have to do? I have to move this over there. It has to be equal to 0. So I have an x plus 1, 2x minus 4, minus 1. I subtracted 1 from both sides. What's my vertical asymptote? Take the bottom, set it equal to 0. So the vertical asymptote equals that 2. We have to combine these two. How do we combine them? We have to get a common denominator. This one has a 2x minus 4, so we need a 2x minus 4 on top and a 2x minus 4 on the bottom. One times 2x minus 4. We did that. Now we have a common denominator on the bottom. Since we have a common denominator, we'll just worry about the top now. So we have an x plus 1. The negative distribute, so it's minus 2x plus 4. On top, combine like terms. X minus 2x is negative x. 1 plus 4 is 5. So our denominator is still the vertical asymptote is still positive 2, but now we can find a 0. Or x-intercept. Set the top equal to 0. X equals 5. I move the x over since it's negative. So my x-intercept, my critical values are at +2 and 5. But that +2 is a vertical asymptote. Do I have a horizontal asymptote? Yes, we do. Because remember, to find the horizontal asymptotes, look at the leading terms. They both have the same exponents. So the horizontal asymptote will simply be the leading coefficients. -1/2. That's the horizontal asymptote. So my intervals are going to be between -infinity and 2. Two and 5. Well, 5 we can use. Why can't we use 5? Because the answer can equal 0. And where does it equal 0? When x is 5. Now we check each of these intervals. For this first one, I use 0, 3, and 6. So we have 0 plus 5 over 2 times 0 minus 4, which gives us +5 over -4. Is that less than or equal to 0? Yes. So we can use this interval. How about here? So we have -3 plus 5, 2 times 3 minus 4. So 3 minus -3 plus 5 is 2. 6 minus 4 is 2. Is 1 less than or equal to 0? No. So we can't use that one. Six plus 5, or -6 plus 5. 2 times 6 minus 4. -6 plus 5 is -1. 12 minus 4 is 8. And that one works. So our answer is that. And the last one. Number 7. X minus 3, x plus 4 is greater than equal to x plus 2, x minus 5. What's the first step? Yeah, make it equal to 0. So move something over to the other side. So we have x minus 3, x plus 4, minus x plus 2, x minus 5. Put parentheses around everything. Is greater than equal to 0. So here at this point, I could find my vertical asymptotes. Set the bottoms equal to 0. We have x plus 4 equals 0, x minus 5 equals 0. Combine them to find our zeros. So this one has an x plus 4. This one needs an x plus 4. This one has an x minus 5. This one needs an x minus 5. So on the bottom, we have common denominator. So on top, we have x minus 3, x minus 5, minus x plus 2, x plus 4. Simplify the top. We got to multiply these together first, and then subtract them. X times x is x squared. Negative 5x. Negative 3x. Positive 15. X squared. Plus 4x. Plus 2x. Plus 8. Combine the middle terms, so it's minus 8x plus 6x we have a negative sign here. We drop the first one. There's nothing in front of this. We just drop the first parenthesis of the bracket. We have x squared minus 8x plus 15. And distribute that negative sign. So just change everybody's sign inside there. Positive x squared becomes negative x squared. Positive 6 becomes negative 6x. Positive 8 becomes negative 8. Combine like terms. X squares cancel. -8, -6 is -14x. 15 minus 8 is a +7. Since we simplified it, we can now find our zero, or in other words, our x-intercept. Take the top number, set it equal to 0. So 7 equals 14x. Divide both sides by 14. So x equals 1/2. So our vertical asymptotes were at -4 and 5. My 0 was at 1/2. And the equation that I ended up with was -14x plus 7, x plus 4, x minus 5, which I'll use that equation to solve it. So at -4, we have a vertical asymptote. At 5, we have another vertical asymptote. And at x equals 1/2, we have an intercept. Since we have 3 critical values, we'll have 4 intervals. 1, 2, 3, 4. Because it's a greater than equal to, I can include my 0. So at the 1/2, I put a bracket. Pick a test value from each one of these. So I'll pick -5, 0, 1, and 6. Pick the simplest one you can find. Now we plug them back into this equation and see which ones end up to be positive. That's all we want is positive answers. So we have -14 times -5 plus 7. -5 plus 4. -5 minus 5. Is it greater than 0? -14 times 0 plus 7. 0 plus 4. 0 minus 5. Is it positive? -14 times 1 plus 7. 1 plus 4. 1 minus 5. Negative 14 times 6 plus 7. 6 plus 4. 6 minus 5. Again, all I want to find are positive answers. Negative and negative is a positive, so the top's going to be positive. Negative and negative, the bottom's going to be positive, so this one's going to be a true statement. 0, positive, 4, negative. Positive and negative is negative. This is going to be a negative, so this is not going to work. No, I'll go ahead and work it out. So negative, negative is a positive. Positive 70 plus 7. Negative 1 times negative 10. So we have 77 over 10, which is a positive number, so that one works. Positive 7 over 4 times negative 5. 7 over negative 20. The answer is going to be negative. Not going to work. Negative 14 plus 7. Positive 5, negative 4. Negative 14 plus 7 is negative 7 over negative 20. The negatives cancel. That one will work. Negative 84 plus 7. 10 times 1. So negative 77 over 10. This is going to be negative, so that's not going to work. So the only parts of this graph that will work are these two parts. I'm not going to like it. You have to know the stuff we did in earlier chapters, because that's all we're doing here is using stuff we used in earlier chapters. You have to know how to move equations around. You have to know how to simplify them. I mean, calculators won't work here. You have to set them up first. And that's it for today then. Next time, we're going to do section 2.3. Composite functions. And then we'll start chapter 5. All the way to 5.6. Chapter 5 deals with logarithms and exponentials. Or a to the x. In this chapter, the variable will be the exponent now. Up until now, it's always been the base. And beautiful thing, these two are inverses. They're opposites of each other, like multiplication and division. Once you see the structure of these things, it all falls into place pretty quick. And then after we do that, then chapter 6 deals with systems of equations, substitution, elimination, graphing, and I'll show you another method matrices. And we can finish that off in a day, maybe two. So hopefully before the week of Thanksgiving, we should have this whole stuff, all this stuff finished, which will give you 2 full weeks of getting everything done. I'll still be here if you have any questions to show up, or we can meet online or whatever. But I'm gonna try, my goal is to try to finish before the Thanksgiving starts so that you guys can have 2 full weeks to get your work done. Because that's all you need is more time. So, okay, everybody, have a great, safe weekend. Unfortunately, the